Are you tired of writing Cypher in your Python code? Today, all of that changes. GQLAlchemy is a Python library named after SQLAlchemy, an object relational mapper that all of us have come to love.
We are software engineers working at Memgraph, and we build GQLAlchemy. Ivan, could you tell us a bit more and to our viewers about GQLAlchemy?
Of course. So GQLAlchemy is a Python library that provides you with an object graph mapper, or OGM for short. You can use it to directly interact with a graph database, to write custom Cypher queries, to use database functionalities, all from the security of your current Python environment and your comfortable tech stack.
One of the problems that we faced a lot with our enterprise users is that every time we were starting a project, we had to identify which Cypher queries needed to be run in that project before actually starting to build the application. So what we did is create a Cypher file with all of the Cypher functions that were needed to run the project. And we would test them before creating an application so we can identify which Cypher clauses had errors in them, right? So we would test it during a runtime. And that was a big problem for us because it took a lot of time before we actually started building the application and showing a prototype to our clients. So how does GQLAlchemy solve this issue?
So GQLAlchemy implements the query builder, which enables you to interact with a graph database via Python construct. So each Cypher construct, like clauses, for example, match, remove, delete, they are mapped to Python functions and methods, which you can stack on top of each other. In the end, all of them are used to generate a functioning Cypher query, which will be run in the graph database.
Another issue is when fetching data from Memgraph. You would always receive Python dictionaries, which would have, for example, a type, that would be a node, and then inside it you would have labels and then properties as Python keys in a dictionary, and then the values would be free form, right? You wouldn't know which type has which value, which property has which value. So that issue presented very, very often. So how did we solve that?
So we created, for each node and relationship, we created classes. So those classes have properties. And we define properties and also type of that properties. So when you get back that object, for example, node, you know that it has some kind of property and you just reach it like a Python property of that class.
Yeah.
So it's easy. When you want to get, for example, node's name, you just go .name. It's not a dictionary key anymore. It's nothing that complicated.
Exactly. So instead of returning a Python dictionary, we actually decided to use a schema in the form of a Python class that would serialize and deserialize automatically to Python and Cypher syntax. And that was really good because now we could use Pydantic, which is a great Python library for defining schema and models, to do the work for us and serialize and deserialize objects into Cypher, right?
Yeah.
And you had experience working with that recently when you created your Twitch application. So how was the experience? Was it easier?
Yeah, it was much easier. So this time I wrote backend in like 3 days, and before that it took a whole week. So this was much easier. So I had a problem which I wanted to solve. So I used data from Twitch API, and I wanted to create a whole graph database out of that. So I had some kind of graph schema in my mind.
Okay.
And I just started by creating classes in Python. So I had a user, and I had a streamer, and each streamer is actually also a user. I had a team node, which is actually like each user is part of some team. Also, user speaks some language. Also, user plays some game, and users can communicate with each other via chat, so they chat with each other. And I said, okay, let's create this. I need to create classes. So user is actually a node, streamer is actually a node, but streamer is also a user, so how can I do that? So I just created a streamer class which inherits from the user class. So now my streamer also has labels user and streamer, what I wanted. So that was really cool because it was really easy to do that with GQLAlchemy. Also, when I wanted to create a relationship between two users, so they chat with each other, I just created class chat with, something like that, and then it inherits from a class called relationship. And I just gave a type to that class, and type is like chat with, it's a type of relationship which I used before when I was creating with Cypher. So it's a type of relationship which will be shown in the database.
Oh, cool. So you found a way that you can have like a done model, graph model, which you actually just copied from the Twitch API, right? Yeah. And it wasn't so nice, wasn't so pretty, and you wanted to define some models in Python which were up to your standards and...
A little bit different, yeah.
Yeah, a little bit readable, but you can map them easily in the class definition, so you wouldn't have to propagate that on every object, right?
Yeah, and I didn't have to think about what's else there. Like, I used that in my Python code like I wanted.
Yeah. Okay.
So is there any other benefit to using these schema definitions? For example, maybe validation?
Oh yeah. So one of the things that you can do when defining a class is go over the properties. So think like this. In Python, you have this concept of data classes. And you can define properties of a data class and give them types. But also, we created it in a way where you can give functions that would validate the values of those properties. So you could, for example, say that age of a user could be between 0 and 120, because no user can be older and probably is not older than 120 years. So that's one thing that you can validate. And we did that because in one of our other projects, we had a lot of inconsistencies in our data model that we wanted to solve like this.
So I also wanted to mention that it was pretty easy to define uniqueness of some property, also to index a property on some label, because when I used to do it with Cypher, it's like that long string. And now on each property, I just give them a property like unique, true, something like that, index, yes, I want to index that property, and it's pretty easy to use, I would say.
Yeah, what actually ends up happening is when you create a class and when Python parses the class definition, it runs uniqueness constraints, it creates indexes for the properties that you defined, that indexes need to be created, and other constraints like exists or, as you mentioned, uniqueness, right? And those properties can then be used as, let's say, primary keys in a graph database, because you can use a skip list to get info much faster, right? And there is another property that we've added to our field method, and that is on-disk storage. So can you tell us a little bit about why was that, and what do you need on-disk storage when you already are using the database?
There were many use cases that utilized large files that also needed to be saved as properties, but it kind of doesn't make sense to have them in memory because Memgraph holds the whole graph in memory, and these properties are now saved to disk in a key value store. For example, Parquet files or other large objects. They're not needed for the graph computations. You only need to know about them and maybe use them later on in your Python code. So GQLAlchemy kind of takes care of that for you. You don't have to worry about how these properties are mapped, how they are retrieved from the disk, and how they interact with the objects that you retrieved from the graph database.
Okay, so are those properties then stored in Memgraph in any way?
No, there is no touch point between the on-disk storage and Memgraph's in-memory storage.
Oh, but then you can't use them in graph algorithms,
Yeah,
right?
you can't use them, but the point is not to use them in your graph algorithms because most often they are not needed. They are just taking up more memory and making the computations less effective.
Yeah, I agree with that. I think that we've seen that across a lot of projects which we were creating for our enterprise users. What else? Yeah, I think there is another thing that we need to mention because Memgraph is more than a graph database. It is a graph streaming platform. So Memgraph can use Kafka, Pulsar, or for example Red Panda to ingest data into it, then create some calculations, and then forward the insights gotten from those calculations back into a stream. So can we somehow use GQLAlchemy to gain kind of an advantage and instead of communicating with Memgraph, just communicate via streams?
Yeah, so I also had that problem in my app. So I wanted to import data in real time. I had a data about chatters. So let's say you have a stream and you have lots of chatters coming in, and I wanted to check which streamer is the most popular one. But each streamer has incoming chatters, let's say. So I wanted to see who is most popular in real time. Okay, so I wanted to create that stream of chatters coming in. And I found it really easy to do that with GQLAlchemy. So I just created a Kafka stream. So I had a topic called chatters, and there were incoming chatters, and I created a stream, and I started a stream with GQLAlchemy just with one function inside it. So it was really easy to define it.
So every time a new user would come into the stream, right? That user would then be propagated to Memgraph via some stream, right? Like via some message in Kafka. And then upon receiving it, you would define a trigger in Memgraph, right? And then that trigger would fire and execute some code.
Calculate PageRank, let's say.
Oh,
or
so
between a centrality, I don't know, whatever you want, whichever you want.
Okay, that sounds like a cool use case. And then that calculation that you've created with that graph algorithm will then be propagated back to GQLAlchemy, right? And then you could use it to present the real-time data in the front end, for example, in the front end application.
Yeah, I use it like that. So I had little nodes. Each node had a different radius based on the page rank or between a centrality. Is page rank or between a centrality. So like if you have a big node, it's actually a pretty popular user, I would say.
Oh, okay.
And it was easy to get that data because I just I used Query Builder. I matched node which I want to receive, like all nodes, and I just received their page rank.
Oh.
It was easy.
I think this is a fun use case. Do you think that application is simple enough that you can code it live for our users?
Oh, well, I can try.
Great, let's do that.
So now I'm going to show you how it's easy to create everything with GQLAlchemy. I'm going to define whole schema of the things I'm doing, so of the whole database, of the Twitch data. And let's start. So we'll dive in, and I have a help of these guys. They'll explain a bit everything that's happening along with me coding here. So let's dive in. First, we have to import GQLAlchemy. Like from GQLAlchemy, I'm going to import Memgraph, and I'll show you now. So GQLAlchemy, import Memgraph. And this is useful because here I'm going to create a variable called db, and that db is going to actually be a running Memgraph instance. Exactly. That's how we are going to connect to running Memgraph instance. And after that, I want to create a class user. That class is going to inherit from the class node, like we explained earlier. So I have a class user, and it inherits from node. Next, I want that each user has a username, and that username is actually its unique property. So I have a way of defining this. It's pretty easy with GQLAlchemy. It's a string, and I have to add a field to it. And yeah, as you can see, I forgot to import node. I have to import that from GQLAlchemy. So it's like this. And also I have a field now. I'm also importing that from GQLAlchemy. And within this field, I'm going to define all constraints that I have on this property. And also I'm going to give it an argument db because I want to save that into Memgraph. So I have a unique. And it's true because I want it to be unique. Could you, Mislav, explain us a bit about this exists constraint?
Yeah, perfect. So what's happening is now that we have inherited node from node, is that when we run this code, the constraints are going to be created within Memgraph. They're going to be a uniqueness constraint and an exist constraint. And also there is going to be an index on the field. Now, this exists constraint actually says that no node of label user can exist without having this property username. Yes. And also one thing that I would like to mention is that the type that we gave to the username is string, and it is obligatory within the Python object. If we wanted to have a field which is not obligatory, we would use an optional argument from the typing library, right?
Yeah.
Can you show us how that would look?
Yeah, sure. So, for example, I'm going to import optional. So from typing, import optional. And here, let's say I want to know when we created this user, but I want to keep that like privately. I don't want to save that into Memgraph. So I'll say created add, and that will be some optional date time. Okay, I need to import date time, right?
Yeah.
So we import date time. I want this to also be date time. So datetime.datetime. Okay. So now this is actually an optional property, but it's only here. It won't be saved into Memgraph. I didn't give it this field part. So if I gave it this field part, even without declaring a database, it will still be saved into Memgraph. So you don't have to use field here. You shouldn't use field here if you don't want it to be into Memgraph. And that's it. So it's easy as that. You can use whatever properties you want that are maybe useful to you in this script.
Yeah, field is actually a function that creates those constraints, right? And tells Memgraph that it's going to use these properties, as you've already mentioned.
If you have used Cypher, you know that you have to define this in different Cypher queries, and it's not as easy as this.
Exactly.
Next, I'm going to create a class called streamer. So I mentioned before that each streamer is actually a user. So it's pretty intuitive here to just go, okay, I have streamer, and then streamer is user. Nice. But what I had here, I had a little bit of a problem because when I fetch data from Twitch API, streamer actually had a label stream. And it's nicer for me that it is streamer. I mean, it's easier to handle with. And then I will add this argument. It's called label. So label will be stream. And actually what I'm telling here is that in Memgraph, it's saved as stream. So it has label stream.
Oh, so in Memgraph, the label is stream, but in the model in Python, we have the class name streamer, right? So it makes it much easier to read. And
so when I'm writing any further code, I just use streamer. I don't have to deal with everything, what's inside Memgraph, because this does it for me. So that's great.
Does it also have the label user because it inherits from the user?
Yeah, great.
class?
I forgot to mention that. Yeah, when we are inheriting from the user, it has multiple labels, and I wanted that. So it's now user and stream inside Memgraph. And for me, I know that streamer is a user, and that's it.
Oh, that's cool.
Yeah. So streamer also has property username because it inherits from user, and it's also unique. Then I will write a couple properties here that I want to have, which we are going to fetch from our database later. Okay. This is the number of followers for each streamer and also total view count. I will get this from CSV files, which I already fetched before. I will show you which functions are doing that.
So you put the type to be optional, right? So that data might not be present in the CSV files that you're getting, right?
Yeah, actually the only important thing is the username, because that's like a unique ID of that user. And if I have followers, great, number of followers, great. But if I don't have that data, I still want that user to be in the database. That's like the reasoning.
Is there maybe an option of defining default values?
Yes, you can define the default values also in the field. So, for example, if I want that each user default total view count, let's say they have like some kind of minimum of 10 viewers, I don't know, 0, yeah. Right, that's a great example. So I would put, like, if I don't give that user total view count and I want it to have total view count, then I would put like this, default equals 10, let's say.
You can put it without a string, right? Because
yeah, right,
it is an integer.
Yeah, everything is string inside my database, but yeah, I can put it like integer.
Okay, great.
It makes sense because it is integer. Okay, but that's not necessary for now. I can leave it on, doesn't matter. So I have total view count, and now I want to create a relationship, and I'm also creating another class, and that class will be called chats with. So I want each user can chat with another user, so chats with, and it actually inherits from the relationship class. And I have to give it another thing, so another argument. Okay, I need to import it first. I forgot about that. Nice. And I have to put type to it. And could you explain a bit about this?
Yeah, sure. So graph databases have labels for nodes, but they have types for relationships. And when dealing with labels, each node can have multiple labels, but when dealing with relationships, every relationship can have only one type. By default, the type is named after the class name. But usually when using graph databases, you want to use capital letters for the relationship type, which is why you have to define it here manually, because we want to use chats with in a capital manner.
Yeah, that's about right, but I'm going to add here one property. I mean, I don't have to have property here, but I wanted to create a property like last chatted at, just to give you an example of what it would look like if we want to have a property on the relationship. It's possible to define that.
Exactly. So each edge or relationship in a graph database can have some properties, but the difference between a relationship properties and a node properties is that you cannot have constraints on relationship properties. So there are no uniqueness constraint indexes or things like that. The best thing that you can use for finding relationships is the internal ID of graph objects in graph databases, so that when you want to find a relationship, you can use a skip list within Memgraph, and that's already built into GQLAlchemy.
Yeah, so the next thing we have to do is actually put some users into Memgraph, streamers.
Yeah, sure, let's do that.
So I have a few functions which are already implemented. They are in loading.py, so I'm going to go from loading.py, from loading, import. I'm going to fetch streamer. Okay, first fetch user properties, then fetch streamer properties, then fetch chats with properties. So these are methods which are actually reading from the CSV files which I have, which I fetch from the Twitch API. And I'm going to go row by row.
And they are returning what? Python dictionaries?
Yeah, dictionary, yeah.
That have property keys, which are actually the names of the properties that you're using in your classes, right?
Yeah, that's it. So I'll say for properties, which I have as a key.
Okay.
so for properties, let's fetch users. So user properties, okay, like this.
And now properties is a dictionary, right?
Yeah, yeah. So I'm going to go like user, I create new user. So just place this here, class, and then I'll unpack this, properties, and just save it. So like this, I mean, it's pretty simple. I don't know if you have ever used a Cypher query before, so I used load CSV clause before that, and I mean, there were like 10 lines for this data
Simple,
import. Yeah, so this is
much easier.
much easier.
There is another way of defining saving nodes, right? You can say db dot save node, and it does the same thing.
But just I have to.
Yeah, but could be a little bit more readable. Depends on what you're used to.
Yeah, I mean, I like the first one better.
It's shorter, right?
Yeah, it's more intuitive maybe. I don't know. I mean, both of them are great. Then next, okay, I'll want to fetch properties from the streamer properties. Okay, in fetch streamer properties. And okay, let's do streamer. Also, I'm gonna unpack these properties. Okay, and also save to database. So this is actually like the same thing I did before. But next thing I'm going to do is I'm going to create a relationship that's a little bit different. So let's go there. So I have properties there. These are different keys, like you told us. So I have properties. I have user one, like one user chats to another user. User one, then user two. And I have fetch chats with properties. Okay.
What does this function return?
So it returns dictionary with keys, properties, and user one and user two. Right?
What is the type of user one and user two? It's the type user, right?
Yeah, it's user. I mean, if it's a streamer, it's also user, and if it's user, it's user.
Oh, okay.
So actually, that's not a big problem. Actually, the only thing I need to define this relationship are their eternal IDs. So I have that. So you can, I mean, any one of you can tell us what are internal IDs actually, what I'm talking about. I mean, yeah, you can explain a bit.
Sure. So within graph databases, there are internal IDs that are used for graph objects. So what you need to do when creating a relationship is define what is the starting node for a relationship and what is an ending node. And in GQLAlchemy, we do that by defining the start node ID and the end node ID. So when creating a relationship, you need to give it 3 arguments. The first argument is the start node ID. The second argument is the end node ID. And then the third argument, or more of them, can be the properties of the relationship.
Yeah, so as you can see, I added that while you talked about that. Okay, so I forgot to add something. I don't see, I need to just, like this.
Oh,
okay,
so your font was too large,
yeah, my
right?
font was too large because I want to show everything, and now, okay, that's it. So I saved it to the database. So let's now show what we can do with the query builder, maybe.
Okay, sure. So at this point, we have created some classes in Python that map to graph objects. And then we have loaded the data from the CSV files that were fetched using the Twitch API. And now that we have defined all of the relationships in the graph database and all of the nodes, we can use that to show an example of using a query builder to fetch, for example, can we fetch a streamer if we know its username?
Yeah, especially because we know that the username is unique. Okay. So we have a couple of methods of doing that, but I think Ivan would know the best about query builder, so you can actually help me here. I'll go like match node, I'm not sure. Okay, let's see. So first I want to fetch a streamer whose name is Fatality. Okay, I'll go like, I'll call this variable Fatality, okay. And then, okay, let's first do the matching and then we'll think about other things. Okay, so like what's the way like of doing that?
The first thing you need to do is import the match.
I always forget about that.
Function. GQLAlchemy.
So nothing is imported. Okay.
Okay, now that we have the base, we can start with a match query, and now we need to define what we're gonna match. So first is node.
Okay, node.
So .node, and in the argument section you will define which label you are searching for and which variable to save this node to.
Okay, so like label is stream. I need to remember that now.
Yeah,
Okay.
stream.
And then variable.
Probably
Okay.
can be streamer.
Streamer. Okay, we're going to use that a lot, I think. So I'm going to put like some variable called streamer, and I'll put a string to it.
Nice.
This will map nicely to the Cypher syntax.
Exactly. One thing that you can do, instead of saying a label is stream, is giving a class name, which is streamer, and then saying .label. That way you're sure that you will not create any bugs, right? Because it would not be error prone if you use the class name.
Like if I put it like this,
streamer.label.
Oh,
exactly.
this is much nicer.
But it would be great if you put the label equals argument before that, just to make sure.
Oh, I get now. Okay.
Just to make sure that you know which argument is getting mapped to what value.
This argument is full label.
Exactly.
Okay, streamer.
Exactly. Now it's
okay.
readable.
But I just remember now that actually we know that this will be one result. Let's add that.
Okay.
So we have a method called get variable assume one. What that actually does?
So there is a variable. So every time you're running a Cypher query, and you know that it is going to have only one result, you can call this function get variable assume one, which takes in result as the first argument, and the second argument is the variable name. So it kind of unpacks it for you.
So I think we also need to return this variable from our query.
Yeah, first I want to do the filtering. Like I want that its name is fatality. So I need to use where, right?
Yeah.
Okay. Then I have where. I'll put, I don't know, this because I want to use streamer. And so what is, okay, streamer. Right?
And what is the property?
Username.
Exactly.
Username is the property. Okay. So equals, right? This is the operator. And then let's say fatality.
Okay. So the where function takes in 3 arguments, right? The first argument is the value. The property.
Actually,
the property, right? That you want to match. The second variable is the operator, and then the third variable is the value that you want to match against, right?
Yeah. Next we have to return, like you said,
Yeah,
right?
so let's use the return method. We can just leave it empty without any arguments because we're going to return everything. And in this case, it will be the variable streamer. So
exactly.
And we have to execute that.
Yeah,
I always forget about that. Okay, and in the end we have to add this variable name from get variable assume one. So variable name is streamer. Is the streamer, string streamer. Okay, so now just explain this a bit what we actually got. We got a whole streamer who is fatality. And if you want to get its followers or total view count, we just go like this, like fatality dot followers. If you want to print that or whatever.
So the type of the fatality variable is actually a streamer?
Yeah, and
okay. So
Python code knows that. And
okay, so it is automatically serialized into the class, right?
Yes, and that's the beauty of it, I think.
Okay, that's pretty cool.
Yeah, total view count, whatever properties you have, it will be recognized here. So that's it, actually. Yeah, I think we showed the gist of it. I don't know.
Yeah, this is probably what's considered the mapping functionality of the object graph mapper.
Yes.
Well, guys, I hope you enjoyed our stream. Thank you for watching, and don't forget to follow us on our community Discord and other channels. Bye, guys.
Bye.
Bye.